Hello, people. Hope everyone's doing okay. Kind of interesting news. I was able to, well, not for tonight, but the music that you're hearing is Stream Beats from Harris Heller. And I've mentioned a couple times that I wasn't able to download all of the lo-fi songs, but I guess for some reason tonight they're all on Google Drive. So there will be more different music next time. So that's cool. But tonight we are again sponsored by PCBWay. Yay! Because we're gonna dive right into it because I'm not sure how much work we've got to do. There's a lot we could do, so I want to dive right into it. So this is possibly the last time. Well, no, that's not true. Well, I may show you the progress, but this might be the last time that we have a dedicated Micro 8088 stream. This dusty. I gotta reprint the shell, so I think I'm just gonna reprint it. There's supposed to be a logo. Now that I have a two-color printer, I will be able to print the logo in different colors. So I'm gonna print it again in black, but I'm gonna put the text up here in white. I didn't print the buttons. So we're gonna finish this off tonight, I hope. With the exception of I'm not going to cover wiring up the button board in the front here. If you're familiar with modern computers, normally they do have a sort of like you hook up a bunch of front panel connector things. That's basically the same thing. So it has there's a start or a power and reset button, as well as two indicator lights, and those get wired to different places on the system. I'm not going to cover that tonight. I'm not going to do a dedicated stream on it because it's really just crimping Molex connectors and plugging them in. So yeah, I'm not going to show wiring up or soldering up that board either. For now, I just have this power reset thing, just a generic sort of Amazon thing. But yeah, just know that I do have I've got the Molex stuff, but I'm not going to talk about that tonight. So, okay, Micro 8088, the new IBM XT. So let me show you the progress, what I've got done so far. Oh, it'd help if I turn on the freaking turn anything on. So, and then would hope if my things weren't lined up. Okay, so as you can see, I populated most of basically everything except for the ICs. So I have all the sockets soldered in, well, with the exception of this memory here. But yeah, just basically we're gonna put the rest of the chips put the chips into the sockets. And the real-time clock needs a battery, so I've got a battery. Then we need to flash, I believe, the video card and the sound card, the OPL2 card. Those both should have ROM chips, so like BIOS chips, like how they teach the card how to work. So we will probably have to flash those two chips. So, but everything else is pretty much done now. This doesn't have a bracket. I'll just kind of, let me do one of these. PCBWay. Yay, PCBWay. Oops. Gosh. Click that. There you go. Cool. The real-time clock card doesn't have a bracket, right? It just kind of goes into the ISA slot, so that's really nothing to talk about. The graphics card has this, I think, like Keystone or Keysight or something. They make these brackets. There's a specific one that they make for any like generic VGA type of card. So that's what I've got here. I didn't have to like get anything expensive or anything fancy. However, here you'll see something sort of cool. I I modeled this myself. I've done modeling before, so this is not like a new thing for me. What I did was I took the KiCad project for the OPL2 card, including the KiCad project basically. I found 3D models, so STL or step files for the knob, this knob here, and the audio jack. And I also found in the data sheet for the keystone or keyset, whatever, the generic, the blank plate, the blank ISA plate. I found the specs for that, so I didn't find a 3D model unfortunately for that, but I found the CAD drawing. So basically, I exported the PCB and the two models as an STL or step. Actually, it might have been a step file. I imported those into Fusion 360, which I believe, I mean, you'll have to like verify this yourself, but I believe you could use Fusion 360 as long as you're not making any money. There's like a certain type of license. I have a startup license, which is probably expired, but as long as you're doing open source things, I believe you can just use it. Anyway, so I used Fusion 360. So I basically had the hole, where the locations of the holes, the holes on the card in relation to that. All right, so basically the bracket is based off of the location of the holes here. And then I basically 3D modeled it around that. So it's the same thickness as the keystone bracket, which, you know, I'm a little bit concerned that it's fragile. Hey Newman, 9 months and no baby. Yeah, I don't know. We'll have to go to the doctor together to figure that out. More kid talk. Or do you mean you, Newman? Oh man, that's a struggle. You'll have to talk. You'll have to reach out to me another time. DM me, and we can talk about that if you want. If you want someone to talk to. Oh, so anyways, long story short, I modeled this in Fusion 360, and then I printed it, and this is in ASA. So I've got a back plate for the OPL card. I will be uploading this to probably printables, so people can print their own if they want to. Maybe Sergey will link it on the GitHub for the card itself. So I might make some tweaks because the audio, it's just a little, tolerances are a little loose. They could just be, you know, I could probably take these holes in a millimeter or maybe even a mil and a half or something, so just to make it a little tighter. There's no reason for it to be that loose tolerance, but I'm open to suggestions if people have things or want to, you know. I mean, it's a basic thing. Okay, so let's shut up. I would basically, I want to get the VGA card working because, you know, everything else is kind of. I think the system still doesn't have DOS installed on it, so I want to rush to get this VGA card working to see if it works. So I think there's really only two types of ICs for the VGA card, and that's the RAM and the memory, and there's some kind of a ROM. I think, well, it says on here a 27C256. So I've got to get at my programmer, but we'll talk about the memory first. This is on the BOM. Okay, this is new old stock, I think. I don't think these were taken from a. But I think I ordered them on, well, Sergey on the BOM for the VGA card. There's this like suggested sellers or something. I think I actually might have found this on eBay. These probably came from China, so that's where I had luck finding them. They do look kind of scuffed, so there's a high chance that these are not new old stock and these are just scuffed, sucked out of another board. I mean, they look bent already. So, but we're gonna give them a shot. Hopefully they work. So this is just basically memory. You can look at the actual model number if you want to in the BOM. But I think it has to be a certain nanoseconds, like speed, latency speed. So that's what I've got here is the 70 nanosecond. This came as a pack of 5. So just a reminder, you got to make sure that the half moon thing lines up with the half moon, both on, really, ideally you want to look at the PCB and not trust that you put the socket in the right direction. Okay. I should get some deoxit. I got to get some of that in the future, just in case these things are like, need some cleaning. So I'm just going to shove all these memories in there. Should be good. Last one, I'll choose the least scuffed one. Cool. Like a glove. So really nothing special, that's just memory. Now we've got to find this. This is what? U2. I've got to find that in my box of leftover things. So here's all the parts that are left over. All the things that, from my big sack of parts that came from both DigiKey and Mouser. By the way, I was waiting for like a week and a half to get a DigiKey order. Like I said, I tried to order as much as I could on Mouser because the Mouser part numbers are in the BOM. Anything I couldn't find in Mouser, I looked up the same part number on DigiKey. I shipped, and it was like maybe 6 parts total on DigiKey. I shipped it from DigiKey via FedEx, and it took like a week and a half to get to my house. Actually, so I thought I was doomed, and if you've been watching for a while, you know that I'm trying to get this done before Retro World, which is next weekend. So this is why I'm kind of like rushing through this. So I actually ordered it again, but using USPS instead, and that came quicker. But I got both packages anyway, so it kind of sucks. But I double paid for that, but that's fine. Before I continue, I want to give just a quick shout out to PCBWay. Let's visit their site. See if there's anything cool. Let's just see what we got here. PCBWay.com. Whoa, it's huge. All right, let's give a shout out to their. How about 3D printing? Let's talk about 3D printing a little bit. So I actually used their 3D printing service for my Ashita shell, which is still in pieces. I still have some work to do to get my Ashita back in working order. I think I might have blown out one of the via holes, the screw holes. So I put some super glue in it, and I have to re-drill the hole, and then I'll have to. I have these like coarse threaded M2 screws that I have to like screw back in it in one of the spots. So it's kind of a nightmare. I don't really like. Well, I don't blame the type of resin. That's this. I think it's this UTR 8100, which is that. It's like this clear, kind of glossy 3D print. The minute after you click submit at DigiKey, you immediately remember more stuff. Yeah, well in this case it was, I don't know, somebody forgot about it, I guess. Anyway, so this is what I used for the Ashita shell, but they've got all sorts of stuff, right? So they have just basic stuff, PLA. It looks like they have not a ton of colors, but they have more colors than they used to, which is cool. Nylon, which is SLS, I believe. They only have basic colors, right? So white or black. So it's kind of cool. Nylon is what I do have a nylon Ashita shell that I got from Slicer, but I mean, you could do that. You can get it here. ABS, they have basic colors. Same with PETG. TPU, they only have white and black. They have translucent polycarbonate. They have got basic ASA colors, which is cool. They have Peak. Peak is like a high temperature material. They have a 3D printing aluminum, stainless, titanium, tool steel. Dang, that's cool. So they have these cool metal things. Anyway, so that's PCBWay. Link is in the description if you want to know more about them. But yeah, I recommend them. I've used them for all my PCBs, and there's really haven't been a problem. Yeah. All right, let's switch back to this. I've got to find U2. Your Ashita. Yeah, my That's how you pronounce it, right? Ashita? Resin sucks for putting screws in and out. Yeah. And I've just been working on it piecemeal, and it's kind of like, I don't know. Okay, so I'm gonna start taking pieces out of here. I'm looking for VGA U2. Nope. Nope. Here's the parts I'm gonna need for the sound card. You have a nice metric tap and die set. Interesting. Yeah, that's a good idea. I should probably do that instead of just relying on the coarse threads. But oh, here it is, VGA U2. Okay. I have. So what scares me about the here? Let me put all these other things away for a minute. What scares me about this is it specifically calls out to use an OTP, which is what? Does that stand for one-time programmable? Does that mean if this doesn't program right, I'm boned? I don't understand. In the age of EEPROMs, I don't understand why we have to use a one-time programmable. Will I continue the project with or without U2, like the band? No, I'm just gonna end the stream. Okay, just kidding. I won't do that. Okay, let me get my programmer. Programmee. I am using the XG ECU T448. T48 is my programmer. So this is kind of expensive. It's like $75 or something, but it works. Works pretty alright. Okay. So let's visit. We need to visit the. Let's see, micro. I can never find this. Oh, let's see, ISA Super VGA. No, that didn't find it. I always find Sergey's repositories by typing in micro 888 and then going to his GitHub. That's just how I always find everything. Okay, Sergey. And then other repositories, and then it's the ISA Super VGA. Okay, so here we go. Here's what we're looking for. We're looking for this BIOS flashing, or like the BIOS. So it should be what? In the firmware. All right, so let's go to download. I probably already have this, but if I don't, I didn't. Huh. So let's go to let's unzip the GitHub repository. How come my chip programmers are always some cheap China hack crap? Yeah, I mean, I think this brand, the previous the older version is like a gray or something. So I don't know. Just once and done for me. Okay, so firmware. Is there two different versions? I see a D4.01E. Let's see if we can find any info about which version to use. Oh, I wanted to mention. Where did I want to mention? Here. So there's this construction notes. I didn't talk about this before. So construction notes says this is the VGA chip. Okay, so this is this chip here. The TVGA 9000i VGA controller uses a VGA connector pin 12 as monitor signal to detect the type of display. Older pre-DDC. What does DDC stand for? Display data channel. Interesting. So pre-DDC displays made approximately until 1995 had that signal either unconnected for color monitors or grounded for monochrome. Newer displays use that signal as a DDC/SDA signal. Unfortunately, it can result in TVGA 9000i incorrectly detecting monitor as monochrome. If you're planning to use a monochrome monitor, you can skip. Oh. Oh crap. Okay, I reversed that. I thought it was actually, if you're not planning to use a monochrome monitor. Oh, I did read that wrong. I read that incorrectly. If you're not planning to use monochrome monitors, you can skip the ferrite bead 6 and the capacitor 17. So I'm going to use my RetroTink, and probably, you know, I have other VGA monitors. So on the VGA card, I don't have this ferrite bead FP6, as well as there's a capacitor down there or so that I removed. So both of those components are removed because I don't plan to use a monochrome monitor. So that's just a, hey Artemis, that's just a FYI. So please read that note and understand it. Oops. Read this note, this note here, this section, to make sure, you know, that's easy. You just don't populate those two things, or if you populate them already, you just gotta remove them. Okay. So I don't see any information. Let's see if we can find more info about which BIOS to use. I don't really see that. I just see two different types of BIOS, two different BIOS files. That doesn't make me feel good. All right. Well, what do we do? Should we do the, looks like a newer file, BIOS? Are there any notes? Maybe. No, there's no real notes in here. So I guess we're just going to send the newest one. Okay. All right, so we need to open up the XG Pro, which is the software to program things. Okay. Why does it say that? Okay, so it's asking us, oh, a programmer not found. Then maybe plug it into a, let me just replug it. Okay, there we go. Let me restart it because it wasn't plugged in all the way. I'll just restart XG Pro. Okay, good, found it. All right, let's get our OTP. Let's look at what type of chip we got here. Ugh. Get out. Get out. Oh my God. This chip is like, nah, I want to stay in here. Okay. We good. All right, this is an Atmel chip. AT27C256R. Let me just double check out the BOM, make sure that that's what we needed. So go to U2. Yeah, 27C256 UV erasable EEPROM or OTP ROM. I don't know. I'm not really clear on what that means. Maybe if anybody knows what that means. Well, I know UV erasable means that you can clear what's on the ROM and reflash it using a UV lamp. I know that, but OTP, I don't know. And I don't know why you would choose to use this over something that you could reprogram electronically. I'm not sure. Okay, so let's put the IC in, and if you have the same programmer as me, it says to the, well, oh, are you, my cam link is a piece of garbage. Okay, we back? Yeah, we're back. Hey everyone. Okay, so the programmer says the IC with the moon's thing needs to go this way. So let's put this guy down here and close the little thing. Cool. Oh, let me just throw up the PCB logo there. Okay, so now we go back to XG Pro, and we have to. OTB means one-time programmable. It can't be erased by any method. Yeah, so I'm not sure why. I don't know. Is there a benefit to that other than, hey, you know, this is the BIOS that goes with this thing, and like I don't want you to erase it. I suppose that makes sense. But what happens if I make a mistake? Download a new version. No, I don't do that right now. Okay, so let's read. Oh, actually, first we have to. Oh, did it auto detect? No. Let's choose what we've got here. We have an atmel, and it's easier just to type it in here. So this is an AT. It was probably that AT27C 256 R 256R dip 28, right? Yep. Okay, so we're good there. Yeah, I'm kind of nervous to read it. Would reading it do anything? Okay, it's got nothing on it, sure. Okay, so now we need to load the new BIOS, the latest BIOS. So in downloads, under firmware, I'm just going to choose the latest one. I don't know why it says E either. So D4.01E. OTP ROMs are usually cheaper. Yeah, well, in the scope of a $1,000+ recreation of an IBM PC, yeah. But I understand. It's probably more of a, hey, if you find this card in the future, don't program this ROM. Don't reprogram this ROM because you're gonna break the functionality of it. Okay. All right, let's send it. So here's we loaded it, right? Binary, clear buffer. I'm just gonna leave everything to default, sure. All right, let's send it. Program. Here you go, program. It's working. Woo! It worked. Hooray. Neat. So I'm gonna use my thingy here. Wait a minute. I've got a label maker. I've got a Dymo label maker. This is a model, I don't know, label manager 160. Okay, whatever. And I'm just gonna type in the BIOS version that I wrote on this. So that way in the future, if I know. Okay, so this is. I'll put 2 rows. So I'll do VGA 9000. It's a cool thing for this is you can actually make 2 rows. So if you hit new line, then it's like it actually can drop, you know, these arrows here mean that it's going to print on the next line. And then I'm going to put D for .01E. Well, E. Okay. All right, let's print it. It's gonna print out here. Whoop. Oh, there you go. Hooray. That's it. Okay, and thankfully it's pretty small, right? It's small enough to fit on top of our ROM. I'm actually gonna cut it, trim it, I suppose. You don't have to do this, but I mean, obviously you don't have to do this, but I don't know. I think it's cool for me to be able to tell in the future if I ever get back, if I ever try to, you know, do anything with this, that I can tell what I put on it. Cool. Probably should clean that off with alcohol, but me, we just rub it. Rub that thing. Hawk 2, spit on that thing. Cool. I don't know. I don't know if that's helpful or not. I probably should have put micro 8088, but, or I say soup. Well, the name of the project is on the card, so I'm okay with that. All right, send it. That's our programmed, hopefully, ROM. It didn't fail. So I'm just gonna bend the legs a little straighter so they fit in the socket. And we could finally do moment of truth things. We're gonna plug this thing in and see if it works. Okay, so let's go here. Just slam that ROM. That's satisfying. Okay, so here's our VGA card finished. Now I mentioned the last time we were here, I mentioned that I was going to check all the pins here. I didn't do that. Well, actually I might have. I don't remember, because I had to hand solder this the TVGA chip on there. I think we're good to go. I've got everything on here. Everything's populated except for, like I said, the FB6 and this C17 or whatever it is up here. It's gone. So that we don't avoid it showing up in black and white. And we just got our VGA connector. So let's slam it into the computer here and try it out. I guess I'm just gonna go in this slot here. This is where the other VGA card was. I need a screw. Ah. Ouch. Cut myself. Something. Okay. All right, let's get a screw for that. Put that in there. I don't really know why I'm screwing it in before I even test it, but YOLO, I guess. Ooh, I don't even know. Actually, I brought the other VGA card downstairs, so if this is a fail, might have to go find that. Heck yeah. Excited about that. All right, sweet. Let's power it on. Okay, so if you didn't know, let's put this in again, actually. Actually, I don't know. There is a header here. There's a header here to have an LED indicator for the what the hell is this called? Compact flash card activity light, but I don't know. I'm not sure it worked. But I'll have to take the card out if I wanted to actually get it to work. So, all right, let's test it. So what do I need? I need the power cord and the VGA cord and a PS2 keyboard. These are dusty back here. Okay, PS2 keyboard. I think it's up here. Yep, got my gateway keyboard. I'm gonna put away my label maker. I just need to make room for the keyboard. Screws over there. I'm just gonna move the computer over here. I wish I had like a 10 keyless 10 keyless PS2 cable or keyboard, because this is huge. I don't miss full size keyboards at all. My favorite size of keyboard is 75%, but this is a 60%. If you're familiar with mechanical keyboards. If you go down to something like this, which has no F keys, that's the reason I don't really like 65%. The difference between 65 and 75 is 75 has the F keys. So I'm a developer, so I use the F keys a lot. So, anyways, that's I'm not used to these giant honking keys. All right, so let's plug this in. So that goes into the computer card itself. Okay. Then we need the power cable for the Pico power supply. So I labeled this also. So this is the right one for the size of the Pico power supply. It's 130 watts or something. But it matches, it has the barrel jack. It has the barrel jack on this end, so that actually goes into the barrel jack on the Pico power supply. Okay. Okay, now this could go, I don't know, down here for a minute. Or no, I'll just go here for a minute. Okay, let's plug it in. Then last but not least for now, I need the VGA cable from the RetroTink, which is, where's it coming from? Here it is. Okay. All right. This is sort of a moment of truth here about whether or not it's going to work. VGA cable going to go into VGA card. You use F1 the most, admit it? F1, what do you use F1 for? I honestly don't know what keyboard shortcut F1 would be. Honestly, the one I use the most is F5, probably to refresh, obviously. But in Visual Studio, to go to the definition of something that your mouse is clicked on, it's like if you click on a function name, if you hit Control F12, if you press that, it goes to the definition of that function in the IDE. So I use that one probably the most. But F11's there too. That's full screen. Yeah, I don't really use many different things. Okay, so here's our capture. We want to switch to a different input. We want to do HD15, but this is RGB HV. Oh my god, I'm so nervous if this doesn't work. Okay, here we go. Got my button, my power button. Oh my god. It works! Holy cow! So sick. Oh my god, I'm so pumped about that. Oh man. Damn, that is so cool. See, this is the problem I had. I think I tried installing something on the C drive here on this oh, who was the person that told me that it might be the compact flash, it might be in a different mode or like the wrong mode for booting. I think someone here told me that. Was it you, Alteracious? I think I have to get a different, I think I might be boned as far as trying to install, or maybe there's a way that we can Google how to change it. But I think that's why it won't boot into DOS. All right, so we're good. It's got some video output, so let's cruise along to the next thing. Let's do the, I don't know what we want to do next. How about the real-time clock? The audio card is basically going to be non-functional until Windows is installed. So let's just populate the RTC card, and then we're going to try to get which is, it's really weird because this is a, let me show you. No, Jesus, what the heck? Here we go. This is a Transcend compact flash. Okay, I have some alternatives. I suppose I can go get the one that boots on. I have one that is for my 286. Maybe I can use that one. But I've got an 8 gigabyte one, which I know if the 2 gigabyte one, I'm pretty sure that the 8 gigabyte one won't. But I have this, which is this is weird AliExpress compact flash to SD. I don't even know if this is gonna work either. This might be too, like, I don't have an SD card that's small enough. I can't even get it out of the freaking package. I don't know. Let's get the real-time clock together, and then, I don't know. Does anybody know anything about that mode thing I was talking about? We're gonna have to Google that. I think that is what we need to figure out. But let's move along to this real-time clock. I don't think we have to program anything. I'm not sure about that. I don't think we have to program anything. I think it's just populating these two ICs, popping the battery in, and then putting it in the computer. So let's move the keyboard aside for a second. Precariously. And let's find the two ICs. F1 opens help. Oh, I didn't even know that. Shows you how often I use help. I guess we could still populate the other the sound card. All right, so I'm looking for all the RTC. That's the OPL. 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 Oh, here's RTC U2, so that's U2. OPL. 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 RTC U1. Okay. So we've got RTC U1, U2. You need to format it as system and bootable. Yeah, well that's a drive flashing thing. I think the I already did that when you do sys or whatever. Yeah. Okay. Well, we can try to troubleshoot that. Oh, I did mention that I was gonna teach you guys how to boot. How to boot into. I'll have to save that for another time. How to properly flash the what is it called? XTCF card, because that's actually a process. You can't just program the IC. You have to program it in another computer, and then program it on the computer through this DOS program. I'm looking for a knife to open this package. That's for another day, I think, to teach you guys about that. That's a topic that deserves its own little video. Because I think that's not explained enough, I guess. So, yeah. Wow, look at this sucker. Dallas. It's a Dallas, this is our real-time clock chip, right? Let's just Google, or let's look at the BOM for the RTC card. Yep, it's a DS12885 RTC. This is it. I think this is pretty much the real-time clock on a chip module thing. So let's plug that in. Oops. Plug that in here. Making sure that our half circle matches the half circle on the board. Yep. Oh, we need to bend the oh no. Okay. Got to bend the chips in a little bit. Cool. Okay, so there's the real-time clock chip. See you later. Okay, last but not least is this guy, U2, which is simple programming logic device. Oh, it's a GAL. So we do have to program this, right? We have to program this thing. This is an Atmel. I don't know. It just says F16V8B 15 PU. Okay, so we might have to actually flash this. That's interesting. Oh yeah, SPLD. Wait a minute. How do I actually flash this then? Can I use my programmer to flash this? First time joining one of your streams. I've watched a few of your videos and streams, but never on the Micro 8088. Is this like a mini computer running off of the 8088 chip? Yes, actually this is basically an entire project. And this is a kind of a pretty old project. By this guy, Sergey Kiselev? I don't know how to pronounce. I think he actually lives in the United States. I don't know if he's originally from, I don't know, his name sounds Russian, so, or you know, some kind of, okay, long story short, I've never heard him talk, so I don't really know what his nationality is. It's not really important either. Yeah, so it's basically a tiny IBM XT. If you think about, well, if you hear about an IBM PC, usually people are talking about the original sort of three. There was three different types of IBMs. There's the IBM PC, which is the original one. The thing about the IBM PC is it's an 8088 computer, but it has no hard drive. It has two floppy drives, right? So you might put DOS in one floppy drive, and then whatever program you wanted to run on the other drive, okay? So you really couldn't save. I mean, you can like write save files and things to floppy drives. Like Oregon Trail actually I think is one that you can save to the floppy drive that you're running from. But that doesn't have a hard drive. But the next one, the IBM XT, is also an 8088, a computer based off of the 8088, but it has some interesting features like, well, the most interesting feature is the hard drive. So it actually does have a hard drive. Now, this is kind of like way far removed from an original IBM, but you can think of the actual base IBM XT system as a combination of this card here, which is actually the CPU card. I actually don't have a PPU populated. I could get one if I wanted to. So that's the actual CPU card, is this one here. But it's also paired with this backplane here that lets you plug in other 8-bit ISA cards to it. So that's like the base of this whole project, along with the 3D printing enclosure. But I mean, this is a fraction. This is essentially, it's less than a quarter of the physical dimensions of a real IBM. It actually might be the same sort of thickness, like this height. I mean, if you took this height and then you multiplied it by like, I don't know, like 10 or 12 maybe, that might be the same form factor of the original IBM. But it has the same functionality with a twist, right? So we've got a floppy drive controller, which I guess you would have had a floppy drive controller on the original IBM, but this also has an integrated serial port, so we got serial in the back for a serial mouse, I guess you could use it for that. Then the next card we have is actually the VGA card that we just worked on, so that's video. But at the time of the IBM XT, you would have had something like, most likely you would have had a monochrome display card. You would not have had a color display. I mean, because at the time, you know, everything would have been monochrome anyways. So the next step up for IBM was CGA. So this isn't even a CGA. So this is like, CGA was only 4 colors, whatever. Then after CGA was EGA, which is 16 colors, whatever. Then after EGA was VGA, and that was not until, I think it was probably late 80s, versus the XT would have been like early 80s. So it's kind of off by the VGA card, I suppose, is off by, it's not necessarily period correct. So if anybody ever developed like a, I don't know, monochrome, I don't know, even CGA I don't even know if CGA would run. I don't know. You'd have to. I guess you could have a CGA card in here. That'd be the most like period. Might be the most period correct thing that you could still game on. But I think VGA is backwards compatible with those modes, so you could run software that's meant for CGA on a VGA card, I believe. Then the last one here is kind of way different than an IBM PC. An IBM PC would have had its own probably hard disk or MFM drive controller and an MFM style drive. Versus this, we can make use of a project called XT IDE. I guess that's for a 16-bit bus, but if you have an 8-bit bus, you can use XTCF. Basically, it's a way of taking a compact flash card. Actually, compact flash is the same, has the same pinout, and it uses the same. Wow, that focused well. It has the same number of pins, and it's the same type of thing, I suppose, as IDE. So this is actually kind of equivalent to IDE, but just a lot smaller. So basically, it's like trying to use an IDE hard drive, but flash based because it's got this CF card. But so instead of having to have a mechanical hard drive, we're using an IDE controller that it's integrated into this card. It's basically an IDE controller that converts a compact flash disk or this memory card to IDE all in one card. And it does other things too. The XT IDE kind of like, it allows this computer to be able to access larger disks, larger, drive sizes, because there's no way this computer would have been, the era of an IBM XT would have been in a megabyte, region of disk space. So, Hercules, yeah, Hercules would have been black and white. So yes, long story short, if you passed out and you just kind of didn't listen to what I said, or if that was too lengthy of an explanation, it's essentially a brand new, as brand new as you can get in 2024, IBM XT class machine. So yeah, it's cool because this is kind of, at least on the PC side, this is where PC computing sort of starts. At least in my opinion, or I'm not an expert, but so any like DOS programs might have started around this time. So that's why it's kind of like it's like the NES, I suppose, the NES of PCs, right? Because this is the kind of the beginning, maybe the Atari of PCs. All right, I know that was a long-winded explanation, but yes, this is an 8088 mini computer. Yeah, functional. So it's like a clone of the IBM XT. All right, I'm going to shut up. We got to figure out how to program that PAL chip, or the GAL chip. Sorry, I think Adrian's Digital Basement says PAL or something. So this chip, well, can I program it with my programmer, or do I need a special thing? How's the progress going so far? I heard in one of the other streams that you had trouble installing DOS. I think it was related to. Somebody somewhere else mentioned that there's like 2 different modes that a compact flash drive could be in. There's like let me just Google that. We're gonna have to figure that out pretty soon because that's kind of my next bottleneck. I can run DOS. So let me back up. Let me show you another thing. So because it has a floppy drive controller, so this top card is a floppy controller. I'm actually using. You could put if you had a 3.5 millimeter floppy disk drive, right? Because it's compatible with if you had like a 3.5 inch floppy disks. If you had those and you wanted to use those, it is like this spot in the top of the case is actually designed to fit a 3.5 inch floppy drive. But ain't nobody got time for that, and I'm not going to buy floppy drives for this. So I'm using Flash Floppy is the firmware that runs off of this, but this is actually a project called OpenFlop. So it's an open source floppy drive. It's the open source hardware for the Flash Floppy project. Normally Flash Floppy is used for Gotek drives. So you can buy Gotek if you just Google Gotek on Amazon. You can get pretty inexpensive drive emulators that actually act like 3.5 inch floppy disks, but you can store the images on a USB. But the interesting part about flash floppy, which is a firmware that you have to flash your GoTech to because it doesn't come with it by default, is there's a screen here. Well, you can get GoTechs that are already flashed with it. But there's a screen in the front here. Let's just power it on for a second. There's a screen that shows you the name of the, I know you guys are gonna not be able to see it very well, but it shows you the name of the floppy drives that, or the floppy disk image that's loaded. So I can actually cycle through the images on here, and then it acts like I put the disk in the drive. So this is how I'm installing DOS or loading a game or something. It's off of here. So it's kind of like the flash cart of of these retro PCs for, or at least, actually there's firmware, flash floppy firmware that runs on most types of retro PCs. So as long as you have the right interface, like connection, you can connect a GoTech or OpenFlops to it and run it. So like Amigas can run flash floppy as well. There's actually some like weird like keyboard synths and stuff that actually have floppy disks in them, floppy drives in them that you can load stuff that way. It's kind of neat. All right, so it's kind of choose your own adventure right now. I've got to, in order to get the real-time clock card, which, where'd it go? I guess we have to flash this in the GitHub for the real-time clock. It says SPLD. I don't know. Does that mean I need a different thing to flash this? So I guess I can just shut up and Google how to flash it. Red tape. Okay, so let's go to the window. All right, so I'm just gonna Google how to flash. It's this. Excuse me. How to flash that. Okay, EEV blog. Programming ATF 16V 8P PLD devices. Should be supported by universal programmers. Okay, great. Okay, so that means we can use our universal programmers. So let's get the this guy back. This should be pretty easy then. Let's just get this out of the way and then we can focus on the trying to figure out the card situation. All right, so the half moon is over here, so that goes down here on the programmer. Let's close it up. Shoop. Now we switch to XG Pro. All right, so let's find it here. If we select it, we gotta type it in. So actually, it should be in my Control F already. My copy paste, I mean already. So we have ATF 16V8B. I'm gonna guess that it's that. I don't know if the dash 15PU makes a difference. But yeah. All right, so now I need to download the RTC GitHub project to get the firmware. So let's download this. And then we can unzip it. All right, so now we gotta load it in the programmer under SPLD. Is this JED file? JED. I don't know, is it? Let's go back to the I don't know. Programming SPLD. let's just do JED. What is JED? Can I program a CPLD with only a JED file? Yes, to program a CPLD from Xilinx, you need a programmer and software like Impact, and of course, the JED file for your CPLD. Okay, so it is just the JED, I guess. All right, let's send it, right? Let's program it. It's working. Yay, successful. All right, neat. All right, so that's it. Let's put this guy or girl, I don't know what gender it is, or non-gender. I don't know why I personify chips, but hey, sorry. All right, let's put this in here. Yay. Okay, so I didn't mention that this was one of the cards that was missing. This is a real-time clock card that basically the only purpose is it gives the... Actually, there is something I didn't even talk about with the... Oh, okay, never mind. It's not on that card. I'm not sure what address to use here. All right, so I know that we need to put the battery in. So that's step one. I do not know what there's dip switches here. I don't know what they need to be set to. There's different addresses here. I don't know. Don't know what addresses we have on all the other stuff. I guess what we should do is try to run check it. Is check it going to tell us what ports are open? I think so. I didn't remember to... well, okay, let's put this aside for now. So I think that should be fine. The only thing is, I think we need to figure out what address it needs to run on. And that's not going to be easy for me because I don't know. So just know that this should be fine. I just don't know about the address. So we're going to worry about that in a minute. Let's worry about the last thing that we've got here. Let's populate it, I suppose. This thing. This is the actual sound card. I just want to populate it and maybe flash the firmware. And then we can try to figure out the compact flash thing. Although, I mean, it sort of doesn't really matter because I can't use this. Well, I guess I could, right? We might be able to. I don't know. I don't know how we're going to demo this tonight. But let's just get it populated. So I have all these different chips. Take them all out of the box. I also have the actual OPL2 chips. So let's start with those. So this is the DAC. So the OPL2 synth chip is actually this chip. Let's get the cleanest, dirty OPL2 chips. How about this one? This is pretty white, pretty clean, I mean. The other ones are kind of scuffed. Oh, yeah, so these are like ripped out of something and desoldered. I could just tell that the pins had solder on them at one point. Let's bend the pins flat. Okay, so they're pretty straight. Now this goes here. This is, it says on the solder mask, YM3812, and that's what this main chip is. So let's put the main Yamaha chip in. I think I got those on eBay. Okay, so let's put that away. That's the synth chip, but along with that we need the DAC. So I've got a bunch of these DAC chips. Whatever, I think these are all kind of the same cleanliness. Make sure that address you pick is free. Yeah, I know, alterations, I know, I just don't know what's free on the system. I didn't remember to, I should have like wrote it down. I think we should be able to tell if we like boot into check it, I think should be able to tell what addresses are being used. I'm not sure. There's two different types of addresses too, right? There's like, I don't know. I know XTCF is loading it from an address. The video BIOS is loading from an address. Yeah. All right, so the DAC. This is the YM3014B. So that's this. DAC goes here. Boom. You should know what addresses are being used by your other cards already. Well, I'd have to take them all out, right? What do you mean I should know? This is like, this is way out of my, I guess I could take them all out and just look, right? I think the only other cards that would have had addresses are the XTCF card and the video card. Well, actually, no. The video card, you can't select anything, so I'm not even sure where that's loading from. What else might be loading? The floppy controller? The serial controller, I mean, maybe? All right, let's quickly populate the rest of these things. So I've got U2 and U3, which are at the bottom here. Sound cards work in DOS. Gotta load the drivers in auto exec. Oh, that's right. Yep. Yeah, I mean, I vaguely understand how to load a card. I'm just not sure if I can get it working tonight and find a program. Okay. I think what I probably would do is like get it all working, get the computer all working, and then do like a demo stream of me just playing some games. I know I'm leaving out some info, which is, it kind of sucks. I wanted to get as much of this. Yeah. See, there's actually these two, so that's U2 and U3. There are actually these two sets of jumpers here as well. So here's an address, and this is the IRQ setting. You have the address and the IRQs, right? So this IRQ is over here, and that's the address. Okay. So I'll probably have to pull out the cards and see what's what. Is there like a default address for OPL2 cards usually? I actually have another, no, I have a Sound Blaster. Not an OPL2. This is my first like actual AdLib card. That's part of the reason I wanted to build this, is actually so I can try to learn more about. Okay, so this is U9. To learn more about what it takes to run, program the cards and how to set them up correctly. Okay, cool. So we've got U9 in there. But serial is usually a standard range. Okay, so I've got U5. I should have just done this before ahead of time. At least the ones that I'm not really going to talk about. That's U5. This one's U1, the octal bus. COM used to be 3F8 IRQ4. Okay, I've got U1 here. I've got Q4. Okay, last one, I think. U8. Yep, U8. Hooray! Okay, well, so there's address and there's also a BIOS location, right? They're two different things. I don't know. All right, let's go to the OPL2 GitHub. Okay, there's not a lot of info about what addresses to use. Okay, so I guess the first thing we need to do is tackle. I'm not going to worry about this right now. Set your look in Discord. Hang table for addresses IQ. Okay. DMA. Okay, let's check that out. Okay, here we go. IO addresses, IRQs, and DMA channels. Okay, so you have IO addresses, IRQ or interrupt request lines, and then DMA is direct memory access. Okay. Interrupt request line is a physical line from the card to the CPU through which to send interrupt signals. In other words, the device needs the immediate attention of the CPU it triggers. Okay, so I understand that. There are usually 16 IRQ lines from 0 to 15, of which many are reserved by the system. Okay. System timer, 0. Is that different then than... Okay, that just is something part of the system then. The keyboard controller is on IRQ1. IRQ2 is tied to IRQs 8 through 15. Okay. COM2 or sound card, COM1. So I've got to find which. Okay, so let's see. So that means I could choose IRQ. Oh, I see. There's 3 different options: 3, 5, and 2. There's little pins. I'm just talking about the left settings here. So there's IRQ. Right. So it says IRQ here. Right to the left of that. Then from left to right it says 3, 5, or 2. That's to select the channel, I guess, right? So 3 is the leftmost. So I'm going to guess that that's probably what it should be. So it says COM2 on this diagram. It says COM2 or sound card here. Let me zoom in. So I'm going to assume that that's what it needs to be. But I hope that my COM, the serial port, is not connected to IRQ3 also. So I've got to check the serial port. I've got to take the floppy card out, I think, just to verify that it's not on COM3. Okay, so I understand that. 8-bit motherboards, PC and XT have only interrupt requests lines from 0 to 7, starting with the AT. Okay, that makes a lot of sense. So there's double the amount of interrupts. Okay, on the 286 or newer. These are extended IRQs provided by the second interrupt controller. Okay. Interesting, I didn't know that. In very modern PCs, COM, serial, and LPT parallel ports are rarely used since many devices that are used by these are now USB instead. So these IRQs may be considered available. Okay, so it wouldn't be in this case. All right, so I/O lines. Each expansion card or peripheral is given its own 3-digit hex number, which is used to identify its address. So this address, this I/O address, is distinctly different from the memory address. That correct? So memory address is like where the BIOS, so like the VGA, a VGA card. Well, I don't know actually how it works on the Super VGA or the VGA card, but like my old VGA card, you can configure the settings, I think, or you can configure the address location for the video, the BIOS ROM. It's like it loads that into memory location. So that's different, I guess, right? That's different than the I/O address. Okay, so let's read down here. So here's are some common I/O addresses. So we have 170H is the secondary IDE interface. 1F0H is the primary IDE. Sound is IRQ3, address 330. Okay. AdLib FM sound or address card. Okay. That makes sense. So if we go back to the AdLib card, the second set of, so there's another row of pin headers here. It says address, okay. It says from left to right, it says 218, 288, 318, and then 388. And there's a star next to it. Or actually, maybe it is 388. Is this the wrong? Maybe the silk screen is not printed right. Well, there's an asterisk next to this far right one, so I'm going to assume that that's what it needs to be. It's weird how these numbers don't add up to that, although maybe these are in decimal and that's in hex. Although I don't know if it's going to be that far off. It's weird how it says this is a 3-digit hex number. Oh, wait, 3-digit hex number. Yeah, so these are 3-digit decimal. Interesting. So I wonder if these are just that's just the decimal conversion of the hex. Nope, definitely not. I don't know. I'm not sure why the numbers are different on the address jumpers here. All right, so then DMA, just to round things up. DMA, direct memory access, permits expansion cards and peripherals to directly access memory without going via the CPU. Okay, so we don't have to worry about that right now. Okay, interesting. All right, so I think that should be okay for the sound card, the configuration for it. Now, I don't know about the real-time clock, what address it needs to be at. Do these addresses even line up? The addresses on this number aren't even the same either. 070, 240, 2A0. I don't know what that's about. These IO address numbers aren't the same. All right, well, that's fine. Let's put the, that looks like 330. Well, here, let's actually look at the, oh yeah, here you can see it here on the solder mask. So right here, so 218, oh. God, this doesn't make this picture any bigger. It says 218, 288, 318, 388. Although maybe it's just an artifact of the, maybe it's 210, 230, 310. Does that line up? It doesn't even, that doesn't even line up either. 330H is 8/16 decimal. Even that doesn't line up either. I'm not sure about that. Windows calculator and programming mode, but I mean, it still doesn't make sense what the numbers are. Let's see. Calculator. That's what in the scientific one? Or is there some kind of math one? Oh, programmer. Here we go. So let's see. 388. Okay. So how about what should it have been? 330H. I don't know. Not sure how these numbers make any sense. 218. I don't know. All right. Instead of me just saying I don't know a bunch, I'm gonna try to. Let me Google. Can't boot DOS from compact flash card. See if that returns. DOS won't boot from CF card XT CF Lite. All right, problems. Oh, there's a minus 0 degrees. All right, is there, let's Google booting. XT IDE card stops computer from booting. Removing XT IDE card allows computer to boot. No, that's not the right. Not enough conventional memory. Click on hex to enter hex values. Oh, I see. So let's enter, let's just try it again. So let's enter 388. Nope. 218. Nope. The numbers don't make sense for what is on here. Or what they should be. I don't know if it's a silk screen problem. Yeah, none of those numbers line up to what it is. All right, should we try? I guess we should try to. Well, let's just try to install DOS again. Or should I try to Google that mode thing? Changing mode on CF card. Let's see. Changing CF card mode. Oh, here it is. Removable CF cards to fixed. This is probably a good place to start. I can try a different card that I have. I'd have to go downstairs to get it. Oh, is this it? Here's an image. Little handy tool for changing a compact flash card's mode between fixed and removable. Fixed is more compatible with older computers, but only a handful of older CF cards can change. I guess we should try this. Can we try this? How big is the card? 2 gigabytes. This shows up in XT CF, so XT IDE it shows up. This is the program I think I remember somebody mentioning worked. It might work. I mean, we could try it. So let's see what is in here. Is it a floppy disk or a disk image? Oh, it's just a file. So we've got to write this to okay. What's the program that lets you write floppy disk image? What's it called? Not disk write. Oh, WinImage. Okay, so let's use WinImage to write this file to the drive here. So this is how you would write. This is how you would make a new fake floppy disk image, right? So if it's like formatting a new disk or something. So you need WinImage. I think you have to register it, but yeah, YOLO. Okay, so first you install the program, then you run it. Okay, so we've got this. Now we need to do File, New Image. It doesn't really matter the size. In this case, any of these formats would work as long as it's bigger than the size of the file. Let's see, the file is only 8 kilobytes, so whatever. Just choose a 144. Just for the heck of it, I'll do 320, sure, whatever. Okay, so that's the size of the virtual disk that we're making. Now, we'll copy that one file onto there. Did it work? How do we inject, I guess? Okay, so we get the one file is on here now. Sorry, I can't really make this any bigger, but yeah. Now we save compressed image. Does compressed images work? Let's see. Are the other ones compressed? No. This wants to be an IMA file. Okay, so image file. So we go to the computer, we'll go to the flash drive, which is the eastfun. Oops, no. And then we'll call it, what is the name of this program? ATC FWCO. ATCFW change. Okay, I don't know what that means. So that's the name of our file, and it's going to be saved onto the flash drive. All right, so that's done. So we have a new floppy drive or floppy image on here. Now, because let's switch over to the RetroTink. Oops. Switch over to the RetroTink. Now, we've got to, at the very top, you're going to see we have XT IDE, or XTCF is running. So we've got to, after it tests the RAM, we have to move the oh, see at the very, very top it says, oh, so I want A. Oh shit, too late. It booted from C, so we need to prevent it from booting to C. I think you have to hit A. This is how you can boot from the floppy. Oh, meanwhile, I'm going to select our floppy image on the little thing there. So I'm going to spam A. I think that's how we select the A drive to boot from the A drive, which is the floppy drive. Okay, so we're, oh, that's, yeah, floppy disk drive, so A. So I spammed A. So now we're booting from A, which is going to be, oh, it needed to be, damn it. That's not what I wanted. I have to boot into DOS first. So let's select. All right, well, I have an MS-DOS 3. I have an MS-DOS 6.22 boot disk. Okay, so I'm going to use this boot disk to boot into DOS. So I got to go back and I got to spam A to make sure that we boot from the hard drive instead of the floppy drive instead of the hard drive. But then I have this MS-DOS boot disk, so we're going to boot into DOS from the floppy. Okay. All right, so we're booting from A. It's kind of slowly booting. Oh, we have the fake seek sounds from my open flops. It's pretty neat. Oh God, what the heck is happening? It's freaking out. What's going on here? Okay. Doesn't like something. Okay. All right, let's try DOS 3. So I have a DOS 3 boot disk. Let's see if we can get out of here. We might have to. I said Control Alt to read banana. Yeah, pretty much. Let's try. I have a DOS 3.3 boot disk, so it's an older version of DOS. Maybe that's why. Control C. Okay. Is this a VGA card thing? Hey Cooper, Control C. What is happening with the VGA card? Is this a VGA card thing? Did this happen to yours, Cooper? This is kind of awkward. Okay, so at least we're in. Okay, I don't know. I jiggled the VGA cord and it fixed it. All right, so now we're here. We're actually in DOS. So I'm going to change the image, the floppy image. Something wrong with my. Okay. Now, I've selected the floppy image that has that one file on it. Oh, and the driver was going nuts. What does that Control C do? It's showing the address of the address of the VGA card. I guess it's not selectable, so it must have its own thing. Okay, so that's the COM file. Okay, you use the DOS 6.22 install disk. Got it. It's trying to load a CD-ROM driver. Interesting. So does that mean that image, that DOS 622, had some disk thing in there? Or is it something from, because I don't have a, there's no, I guess that might have been a DOS thing, right? All right, so there's some instructions on how to use this thing on the card. So we got to type in atcfwchg.com/p/f. Is this gonna work? Stops the process. Oh, okay, Control C stops the process. Okay, so I don't know what this is gonna do, but YOLO. Oh, okay, failed error number 20. The hell does that mean? Okay. Right. Okay, so maybe that's the reason why. Maybe that's why it's failing. Is it's kind of just trying to load a CD-ROM driver. Okay, so can we find what version of DOS do you have installed, Cooper? You have 622? I think we have to go. We can go to what? WinWorld. Maybe the problem was not with the CF card. Maybe the problem was with the version of DOS I was trying to install. PC load letter, yeah, pretty much. Okay, I think this WinWorld PC, we can download DOS. Okay, MS-DOS 622. Here's one that has CD-ROM support, but I don't think I downloaded that one. This one here, plus enhanced tools, is the most downloaded one. I don't want the 622 upgrade, right? Did I put it in a new machine and do a disk part? Oh, I see. So I could have gone back there and canceled the driver load. What are we trying to do now? So we're trying to. I've got the VGA card. It seems like the VGA card is working. The last time I tried to install DOS on this, so I think the XTCF card is also working. I got the XTCF not just flashed onto the BIOS, but also set up using the XT IDE config utility. So it's actually running, so I can load from the C drive. I can load from the CF card. So I tried installing DOS to the from the floppy to C, following, doing all the sys and whatever commands, and it just gets hung up saying booting C. It doesn't actually boot into Windows ever. It just gets frozen there. So that's what I'm trying to figure out now. The VGA card is the hardest part. Oh, the chip, you mean? Yeah. Maybe. So now, I guess I'll just show you what it is doing. I'll show you my conundrum here. So I'm not going to touch anything. It's just going to load from... Try to load off of the CF card that's in the back here. Right, so it's booting from C. But this is just what it does. Actually, it might take a while. Let's give it a minute. I'm going to sit down for a minute. Let's give it a chance to load. I don't have an activity light. Oh, is there an activity light? No. Is there an activity light on the card itself? It's actually not lighting up. That makes me wonder if I have the LED backward. Should I do that? Should I flip the LED backward? maybe it's backward. Oh, okay. Just dropped my programmer on the ground. There's no light flickering on the CF card, XTCF. So I wonder if I just need to flip that LED. So I can't really tell if it's actually doing anything. But this is this is a slow CPU, so yeah. No, I guess I didn't. Should I try that and then start the whole thing over again? All right, let me get my CF reader out. We can try that. So I need what, disk part? Is that a Windows utility? Let's try it all over again. It would load right away, okay. All right, so we need to do what? We need to use disk part. Is that a Windows utility? Let me just Google it. Okay, so I just have a CF reader thing, so I'm plugging the whole thing in here. I'm gonna nuke, just whatever is on here, I'm gonna nuke it. I'm trying to figure out what, okay. All right. DOS, hey. Okay, so disk, oh, that's disk. How do I run? Open the command line, okay. Yes, teach me. Okay, let's see, which drive is it? It's the D drive. D is the CF card. Just ties this disk part. Okay, got this part. Type the list disk. It doesn't say. Well, I'm guessing it's this 2000 megabyte one, disk 3. It doesn't say the drive letter. What is this 4000 kilobyte one? I don't know. That's not the right one. This is 2000 megabyte is this 2 gig one. Okay. So it's disk 3. Select disk 3. Okay. Let me just verify that, but is that true? I don't have anything else, any other things in there. I guess it wouldn't show the total. It's not showing like the total of this card here. Well, yeah, this is an XT CF Lite. Yep. I think it's this. I don't think I have anything else in here that's a 2 gigabyte card. Let me see if I unplug it, right? It should go away. If I unplug it and then do list disk. Yeah, it went away. Okay, so I put it back. And then we type that again. Hey, now it's back. Okay, that's it. All right, so now clean. Okay, so this is fine, right? We want to format, I guess. I mean, I don't care what's on here. I'm going to nuke it because I'm going to reinstall it, but micro 88. Unable to complete the format. Why you do this? Do we maybe have to delete the partition that's on here already? You could skip the format. Okay. Access is denied. I just typed it again and it worked. Okay, whatever. Fine. Oh, it clean nuked it already? Okay, fine. Oh, I had it open in Explorer. Got it. Okay, that makes sense. All right, so that's this part, right? So we got that. Now we can start from scratch, right? Reinstall DOS. So this is good. This should be good now. The only thing is, oh, did I have to type exit? Whoops, that's just YOLO. Yanked it out. Okay, so it's back in. Is there something else I needed to do? Like, did it way before Cooper even said anything. I wish that YouTube had immediate, whatever, no latency for 4K videos. It's annoying. All right, let's just fire it up. We need to go to, I want to install, yeah, there's going to be like at least 30 seconds. So I want to hit A. Now I'm going to go to the 622 boot disk again. Oh, the installed disk? So, all right, so I got disk 1. Not the boot disk, but the installed disk. There's definitely about 30 seconds of latency. You are probably seeing me react to somebody else's comment. I don't know. I don't understand it. I'm not sure if he reads the chat as he. I'm staring at it, so I'm trying to read them as they come in. At least now I was. Banging away at the keyboard. Okay, cool. So we're loading disk 1. This is the setup, not the boot disk. This is just the setup. Disk 1 of the setup disk. Okay, just hit enter, I guess. Oops, wrong keyboard. Setup needs to configure the unallocated space on your hard disk. Okay. Configure unallocated space. Sure. Do that. I don't want to install it from here. Is that what you're using? DOS 622? I have to figure out why that LED is not working. Okay, let's try it. Oops, wrong enter key. Oh, what happened? Still no indicator light on that disk. So it's still not doing anything here. Oh, I have to boot from A again. That makes sense. Okay, so let me restart. That doesn't make any sense. So it has you boot A and then restarts the computer to go back to A again? Or did it did like some sys command or something probably? Okay, F-disk the drive and start to copy things over. Something went wacky. Okay, so that wasn't supposed to happen. It wasn't just supposed to randomly restart. Okay, so let's get back into the first DOS install disk. Excuse me. I gotta figure out why my XTCF LED is not doing anything. Okay, so it's formatting again. Oh, she's just gonna take a assload of time. Well, I have the Cooper. I have the 3.5-inch disc version that's only on 2 discs. This is gonna take forever. Oh, brother. 1%. Okay. Should I have installed DOS 3.3? Is that a lot smaller? I mean, it's doing something, right? Oh, the LED's lit up. Hey, sick. Hey, well, at least we know it's working. No, it's working now. Interesting. I don't know why it wasn't working before, so maybe it just needed to be cleaned in disk part, the CF card. Interesting. I don't have the LED. I have on my whatever power button thing, I do have an LED extension, you know, that plugs into that jumper thing, but it's unplugged right now. So, but I can look at the one that's on the card itself. Yeah, it's set to boot to C all the time because of the CF card, or the XT IDE, I mean. Yeah. I think there's some settings that you can tweak on the XT-CF to make it boot by default into A or C. Okay, so since I have the 3.5 millimeter, yeah, 3.5 millimeter floppy drive. No, 3.5 millimeter hard drive, or 3.5 inch floppy drive version of DOS. It probably has more than one utility, you know, like a bunch of utilities on disk 1 and a bunch and the other ones on disk 2 because there's only 2. Versus this, it probably was also available on 5 1/4. You used to love the format real hard. Yeah, I mean it was. I missed the process of like installing Windows XP and stuff, but this is you just got you had to build it to just sit there and watch paint dry. Yep, that's funny. It's taking its sweet time, and the LED is still lit though. It's good. Crank it into high gear. Come on, CPU, you can do it. Uh-oh. Flickering. No. Don't flicker. I wonder if my, maybe my VGA card is bad. Or cable, I mean. It's possible my VGA cable is getting old. I didn't put it in yet. I didn't know what address to assign it to. Do you know what address? Did you install it? I don't know what address to use. Also, did you do the OPL2? No, I think you chose a different OPL2 card, right? A different kit. I'm not sure what address to choose. Oh, actually, no, we kind of figured it out. But the address on the solder mask of the OPL2. Here, I'll just leave this running. This is going to run in the background. But I'll switch to. We had this kind of discussion before. Here on the XT or the OPL2 card, there's a list of addresses here, and I think the one that we want is 33 or 330, according to this thing, this article that we were reading. Where is it? Here. So AdLib FM audio address 330H. So that's what it needs to get set to, but there is no 330 address on the OPL card. Yeah, I should. I'm installing DOS now. So let's let DOS go. Let's see where are we at. 43. Getting there. The RTC card really only helps when DOS is installed, so you don't have to. I don't like this random flickering. I hope it's just a case of my VGA cable is worn out, and not like a bug with the retro tank or something. 230H, 220H. That's the sound. Oh, for the. I'll have to reach out to Sergey and see what the heck's up with that. Making progress. Yeah, but I mean, default is really, I'm assuming this asterisk on here is the default address. Now, I don't know with the RTC card, it's currently set to 70, address 70. 220H is the same as Sound Blaster. RTC use the default, and the BIOS will find it as he has the BIOS set up to look. Oh, okay. Remember some version of Windows doing flickering when setting up and it being intended, but definitely not DOS. I would assume it's probably the cable. Hopefully. 388 is fine. Yeah, but I don't know what that means. I'm trying to like look it up in this thing here. Come on, go. Okay, while this is going, let's see. What can I talk about? Flickering was not normal. It was on CGA. Hopefully it's not like a... I hope it's just the the cable, but we'll be able to diagnose it more when we're in DOS. So what's left to do? I guess the only card that I haven't done that I think I may do in the future is the network card. Yeah, I didn't do that yet, but that's kind of like a nice to have. But RTC is good, so you don't have to type in the stupid date time all the time, and the ad-lib card, so at least you can play basic games and get audio. I can't plug it in until this is installed though. Then I will. Something third stream. Yeah, I'm interested in telnetting, or trying to connect to some BBSs, because I know there are some BBSs set up for 8088 PCs to connect to. I just think it'd be cool to be able to do that. We're close. We're getting there. 80%. So this is kind of inside info, but I asked Hyperkin. I was super interested in testing the Duchess, which is the Hyperkin's USB. Here, I'll switch to the face cam. So their Type S Xbox controller, the USB controller. So that was the beginning of the month. So August 2nd, I direct messaged them on Twitter and I said, hey, do you have any Duchesses that I can test for review? Today, so it's been like 2 weeks, almost 2 weeks. They said that they ran out of the Duchess controllers, but they want to know if I'm interested in testing. And I'm not saying this to like talk crap about Hyperkin, but they have a new product, which is the N64 Hall Effect stick. So my immediate reaction is, I think it's a GameCube style stick. I don't know what shape the gate is, but I also don't think the gate shape is correct. But it's also a foot in the door for Hyperkin, right? So maybe if I test this, do the controller, the gate test or whatever, just to see how it feels and do the tiptoe test environment or something. Maybe I'll be able to get future Hyperkin things. So maybe it's worth. It might be worth testing this N64 stick. Oh, we're close. Network. Do not hot plug. Yeah. That's funny. The home of the retro battle stations, BBS. So, anyways, I think I might try to review this N64 thing, even though I don't think I'm going to be thrilled with it. But, yeah. I would like to test other Hyperkin stuff in the future, if they have anything cool. All right, let's see. Daytime. Sure, whatever. We can always change it in the future, right? Setup will place your MS-DOS files in the following directory. Sure. Now is the perfect time to fill out your registration card. Okay, so we're copying stuff over, right? The thing is, I don't see the green LED on the CF card, or the XT CF card, doing anything. I do see the floppy disk loading. Maybe the LED blinks so quickly that it doesn't even show it doing anything. Although it's possible that it's just loading stuff into memory right now. Just staring intently at the LED. I put the 8-bit DOE Hall effect stick in your N64, works fine. It's, oh, yeah, okay, we got blinky blink now. So it was just loading stuff into memory. Neat. Yeah, the gate shape on the Hall effect on the 8-bit DOE one was different than the N64. So I have a YouTube video where I tested it when they released their wireless controller PCB. So I'm not, and plus it was when you walked around in Mario 64, Mario kind of like locked in more into like these weird angles. It didn't look very fluid. I think it's not necessarily that it's like not working, but it's just the tuning of like the rates, like how quickly it moves. Like, cause I know they should be able to tune, even if the gate shape is wrong, you can change what value actually gets output, so that it looks more like the stock, shape. So I don't know. I'm not sure. The gate is not completely accurate. Yeah, you install the wireless board. Yeah. It's also shorter, yeah. So people's muscle memory. I mean, it's probably fine for casual people, or if you have a really clapped out joystick and you really just want it to be like the second person controller. I do know that like Rocker Gaming is working on a complete replacement made out of steel, a steel bowl N64 stick. It's kind of expensive, so I don't imagine that's for everyone, but that would be a lot more of an accurate thing. Welcome to the slow and wonderful world of PC XT speed. Yeah, I might have to come back to this. That's funny. Shit, are we really gonna have a third stream? I still have to wire up the little wires, so maybe I should do that between now and Sunday. Because next week I'm off to Retro World. I do have to cut the piece of acrylic too. My dad's got a table saw. Let me show you guys what I'm talking about. So I want to have the side panel be acrylic. I mentioned this before. So I have this 1/8 inch. I got this 1/8 inch piece of acrylic on Amazon. There's some grease or something on this. Ugh, I don't even know what that is. Nasty. But it's just, it's clear, but it just got the paper backing on both sides. So I have this piece. It's bigger than the side needs to be. My dad's got a table saw. I think I'm going to have him help me cut it down, or I can cut it, whatever. I'll just use it. Down to the square size of the panel. And then I can drill holes through it and then use this as a clear thing. Let's see. You press the turbo switch. There's no turbo switch. I think it's a setting, right? I think it might be a setting, like a BIOS setting or something. You did the V20, but it's only like a 5 to 6% speed increase. Not related, but did you change some of the wires out on the Ashita and get it working? Anything still left? So, yeah, the Ashita, I did get the direct drive board working, so that works well. I ended up stripping some of the screws on the shell. So I was waiting to order some on Amazon, or actually at AliExpress maybe. I ordered some M2, their countersunk M2 coarse thread screws on AliExpress. The button board, one of the button boards, because of the thickness of the head of the screw on the screen, it doesn't lay flat all the way. So I asked Wes. Wes actually has a new version of the direct drive board mount, like the 3D print part, that the screw holes that screw the mount to the shell, they're countersunk now, so they should be flat or close to flat, like flush with the actual 3D print itself. So you won't have any difference between the shell or that part. And he also made that the part, it was too thick, I think, so he made that a little thinner. So long story short, he's made an update to that piece. So I have to 3D print that and then get back to that part and swap that part out to make the button board flat. But the piece I stripped, the screw that I stripped, was for the button board. So I put some super glue in it. Then I need to drill a tiny pilot hole, and then I'm going to use these other coarse thread screws to fix that. I'm going to cut cut super slow. Yeah, I mean, I don't have a, I don't know if would a laser cutter cut this paper? I know that laser cutters aren't supposed to be able to cut acrylic, but cut super slow. I might even have to buy a different blade, because I'm not sure my dad's blade he does wood projects, so he doesn't really do acrylic cutting. So I might have to buy an acrylic blade for his table saw. Does PCBWay do laser cutting? I don't think they do laser cutting. I wish they did. That'd be cool. Like even laser engraving would be cool. I'm gonna look it up. Now that'd be a neat service. Selective laser melting, no. Casting, vacuum casting? No, I don't think they do. Some year I would like to buy one of those high-powered CO2 lasers or whatever that can actually laser cut acrylic, because that would be ideal. I could just put that in there and, or the other alternative would be to get a CNC. So you could probably buy a CNC machine, for cheaper than you'd be able to buy a laser cutter that would be able to cut clear acrylic. There's only one blade. Laser cut that perfect. Really? A laser cutter would cut this? Because I have a neighbor that has a laser cutter. Maybe I could reach out to him and see if he would be like, hey, cut this. I have a friend that has a neighbor that has a laser, but he cuts wood with it. But I don't know if it would cut through this with the paper on it. I don't know. I can ask him. We could try it. Well, the problem is I don't think all laser cutters can cut through the clear acrylic. They can etch it. I think you can do laser engraving. All right, how's our install going? Oh gosh, we're way behind. Okay, so put disk 2 in, hit enter. All right, we're gonna have to revisit this. I'm way past time, and my girlfriend wanted me to hang out with her. So I'm gonna let this install. This is gonna be just a basic, I'm not gonna do anything to it yet. So I don't know if I'm gonna guarantee a third stream, but sometime we'll have to revisit this and search Google for laser cutter and acrylic. Do that, I'll be much happier. Yeah, you think the table saw will laser cutter for acrylic? DOS waits for no man. Yeah, true. Ooh, Elegoo makes a laser cutter? I know this X-Tool brand. I've seen this X-Tool brand before. But their stuff's super expensive. I don't have this is the CO2 laser. Come on, pop-ups, what the hell? I don't know. Noob looking for a good low-budget laser cutter. Here, let's check Reddit. Reddit won't steer me wrong. You need a CO2 laser to cut clear acrylic. Diode passes straight through it. Even with the paper? I believe you can etch this way but not cut. I tried to engrave, then cut, reverse print labels, clear acrylic with white backing, and had no issues engraving the white, but the clear would not cut. Yeah. Yeah, I think you do need a higher power. I don't know. I'll search for it, but you're right. I would be better off laser cutting it, but I can't afford can't afford to buy a laser right now. How's our DOS install doing? All right, I'm gonna let this just sit and do this for a bit. So there's still some outstanding things, right? I did promise a stream on actually how to get XT IDE configured, because you do have to make a disk image using WinImage and then load a program. So you have to load into DOS without installing DOS first. I guess you could do it if it's already installed DOS, but from a computer that you're trying to use XTCF on, you probably only have your disk drive. So you have to load this XTCF program from DOS, then you can flash XTCF from the program in memory onto the ROM on the XTCF card, but you can only do that from the program, whatever. It's kind of a weird way. You can't like flash it from just a universal programmer. Never wiped down acrylic with IPA to clean. Yeah, I've heard about that. So that's kind of a complicated process, how to actually install XT IDE. So I wanted to do that, but I wanted to be able to just have DOS installed so I could test the RTC card and the AdLib card and get some games going. So sucks that we didn't get there tonight. But yeah, I'm assuming that this is gonna be better, right? This is gonna work better, maybe. I think I might have installed DOS before manually, so we'll have to see. All right. Thanks again, everybody, for watching. Thanks again to PCBWay here, PCBWay, for sponsoring the video. You can find out more information about PCBWay and the services that they offer in the link in the description. And it came a long way. Yeah, I mean, I'm glad that the VGA card works. That was really stressing me out because of the soldering on there. That's a full DOS install. So I'm excited. Then I guess the only outstanding thing, maybe for the future would be to get the Ethernet card, because there is one slot. There will be one slot left open after putting the RTC card and the the sound card. So thanks, PCBWay. All right. I'm not sure what's going to be next. I have a bunch of goodies to do. I know that Bonzo has sent me a few things that he wants me to check out. And, what is his name? Let me just check his name here on Twitter. Because there's a few, okay, Consoles for You. So from Consoles for You, I'll show this off before I go. They sent me a whole GBA HD kit. This is their new Game Boy Advance consolizer. I mean, I'd say it's new, but this is all based off of the GBA HD project from Zwenergy. It just happens to be an all-in-one style, or AIO style Game Boy consolizer, which you harvest the CPU and the memory from a Game Boy Advance, and you populate it, and the card slot, I think, and you populate it on this board here. Now, the interesting thing about this AIO kit is that you can actually see there's 1 slot, 2 slot, 3 little connectors there. Those connectors are for an interposer board. So this is sort of a universal consolizer in the sense that you can actually use either, what's the wide style Game Boy Advance? I don't know. I don't remember. You could use either the CPU from a Game Boy Advance SP, so this is the SP interposer, or you can use just the normal Game Boy Advance and solder the CPU onto this interposer. So this universal kit lets you use either style of Game Boy Advance. So like basically whatever one you can find cheaper, and then you can harvest the CPU and the RAM from it. And either one will work with this. So I have that to work on. Yeah, but there's a name, the nickname for the wide one. So yeah, this kit is for either one. So this is a truly universal kit. Plus it's the all-in-one version versus the original Game Boy Advance SP that I did, which uses the... so it's based off of this Spartan Edge FPGA from Seed Studio. So this is still the original FPGA board that from Zwenergy's project. So it still uses that, but it really utilizes like a shield, so like it plugs into it. But it's a universal shield that you don't need. So the original Game Boy Advance SP or GBA SP consolizer uses the Spartan Edge board with a shield with the Game Boy Advance SP motherboard on top of it. So that's what this is. So that's this Game Boy Advance SP or consolizer. So it has the shield or the FPGA board, a shield, and the Game Boy Advance SP motherboard in here. But the all-in-one style, you actually you don't need the motherboard itself. You harvest the CPU and the RAM. So I have that kit. I haven't done a Game Boy Advance consolizer in a while, even though I own 4 other ones. I've done 4 other ones, so but yeah. Oh, the AGB, yes, AGB or the AGS. Okay, got it. Oh, so there's 2 different variations of even the wide version. The SP version is easier to acquire. Yeah, it really all comes down to price, right? Because Game Boy Advances are like ridiculous price nowadays. I mean, $80+, which is sad. I feel like they should probably be a little cheaper than that. All right, I've been talking way too long. I'm gonna get I'm gonna get beat. No, I'm just kidding. I'm not gonna get beat. Just for ha-has. What's the progress? Oh, not even halfway done. Okay. Goodbye, everyone. I don't know what we're doing next time. So harvested is probably better to use. Is it USB-C for power? I don't know. Is there some parts missing off of this? I'm not sure. Oh, there's a whole nother bag here. So there's other parts in this bag. I'm not sure. I think it might be. Probably should be. I'm not really sure. But yeah. All right. Oh, AGB is the original Game Boy Advance. AGS is the SP. Oh, okay, got it. All right. Goodbye, everyone. Thanks everyone for hanging out. Thanks PCBWay for sponsoring the video and this whole huge saga. So we'll be back on Sunday with